Hi there. Today we will be reading and annotating Lesson 2 of Unit 1, Gravity and Motion. So take out your lab manual and we'll be beginning on page 11 today. Section 2, Energy and Motion. A 61-meter drop. In April 2018, an amusement park in Ohio called Cedar Point began testing its newest roller coaster. This roller coaster is called Steel Vengeance. A ride on Steel Vengeance will last about 2 minutes and 30 seconds. It will reach speeds of up to 119 kilometers per hour, 74 miles per hour. The first drop is a 90-degree drop of 61 meters, 200 feet. The height of ice slides, water slides, and roller coasters is key to how all of these rides work. The taller the ride, the faster you go. This is because of gravity, the force of attraction between all matter, everything that has mass and takes up space. Gravity pulls objects together. It's gravity that keeps us and all objects on Earth from floating off into the atmosphere, and that pulls all objects thrown up in the air back to the ground. In fact, an informal motto for National Roller Coaster Day, held every August 16th, is, "May the force of gravity be with you." Understanding gravity. All matter has gravity, from rocks to plants, animals, and stars. However, the force of attraction depends on the mass of the two objects. Mass is the measure of the amount of matter that it takes up an object or substance. It's measured in grams. The more massive an object, the more its gravity will pull on other objects. Earth's gravity pulls on all objects on or near Earth's surface because Earth is so massive. Earth's gravity pulls all objects near Earth's surface downwards. Gravity keeps you from floating off into space. Earth's gravity is also what pulls you back to the ground from the top of a water slide. Weight and mass. The gravitational force exerted on an object by a planet or moon is called weight. It is measured in newtons. Here on Earth, weight is calculated by multiplying the object's mass by the acceleration of gravity. The acceleration of gravity, or the acceleration due to gravity, is nearly identical everywhere on Earth, 9.8 meters per second squared. Non-scientists often think that an object's weight is the same as its mass. The two are related because an object's weight depends on its mass. However, mass also depends on the force of gravity. On other planets and the moon, which have noticeably different gravities, an object's weight would change dramatically. For example, the moon is less massive than Earth. Because of this, the gravity is weaker than Earth's, so an object's weight would drop by 83% on the moon compared to on Earth. The object's mass, on the other hand, would remain the same wherever it was. If you are having a chance to highlight in multiple colors, go ahead and try to highlight this in a different color. Really make sure it stands out, because that's important. Weight and mass are not the same, so don't use them in the same sentence to mean the same thing. The force of gravity. Gravity is an attractive force. A force is a push or pull that acts on an object, changing its speed, direction, or shape. Attractive forces pull objects together. Opposing forces push objects apart. Forces are acting everywhere in the universe all the time. Even if you are standing still, you have many forces acting on you. Earth's gravity exerts a force on all objects on or near its surface, pulling everything on Earth's surface toward the center of Earth. Gravitational fields. Because gravity is an attractive force, objects don't need to come into contact with one another to exert a force on each other. Instead, objects have gravitational fields. A gravitational field is the area around one object where another object will feel the gravitational force of the first object. For example, Earth is so massive that its gravitational field extends beyond the atmosphere, pulling on all objects within it, including the moon. This gravitational field causes patterns in the movement. Remember that a pattern is something that happens in a regular and repeated way. Every time you release a pen in the air, the pen will fall back to Earth's surface because the pen is within Earth's gravitational field. Forms of energy. As an object moves within Earth's gravitational field, it forms a system. A system is a set of connected, interacting parts that form a more complex whole. If you hold the pen in the air, the pen, and the ground, if you hold a pen in the air, you, the pen, and the ground form an energy system. The energy of the system will increase or decrease depending on the height you hold the pen above the ground. Energy is the ability to do work. Work is any change in position, speed, or state of matter due to force. Examples of work include heating an object or moving an object. Energy can either be stored or in motion. Energy that is stored is called potential energy. The energy of motion is called kinetic energy. Forms of energy. Energy is never created or destroyed, but it can change from one form to another. When you hold a pen above the ground, a form potential energy called gravitational potential energy is stored within the system. Gravitational potential energy is the energy stored in an object as a result of its vertical position or height above the ground. If you drop the pen and it falls to the ground, the gravitational energy potential energy changes into kinetic energy. Any object has kinetic energy. A dog running across the field has kinetic energy because it is in motion. A ringing doorbell has the kinetic energy of sound. Energy systems. Energy can transfer into or out of systems or objects when a force is applied. For example, imagine that you lift a ball above the ground. You, the ball, and the ground make up an energy system. Your lifting provides a force that transfers energy to the ball. The force is necessary to overcome the downward pull of Earth's gravity. The energy system gains gravitational potential energy because of the ball's position above the ground. The higher you hold the ball, the more gravitational potential energy there is stored in the energy system. This is a cause and effect relationship. The height of the ball causes the amount of energy stored in the system to change the effect. When you drop the ball, that potential energy transforms into kinetic energy as the ball moves to the ground. In a perfect system, the total amount of energy is conserved as it transforms from one form to another. That means that however much potential energy there was stored in the energy system, the same amount of energy will transform into kinetic energy as the ball falls to the ground. However, in the real world, some of that energy is transferred out of the system. For example, friction transfers energy out of a system. Friction is a force that slows motion when two objects rub against each other. Friction slows motion because it causes some of the energy of the moving object to change into heat. Friction is why your hands feel hot after you rub them together. Drag, also called air resistance, is another force that transfers energy out of a system. Drag is similar to friction, but occurs between a solid substance and a fluid such as air. As the ball falls to the ground, it experiences drag as it moves through the air. The force of drag causes some of the ball's energy to transfer out of the system. It's important to point out that energy didn't disappear. Instead, it transferred out of the system. The same concepts can be applied to a roller coaster. Think about the roller coaster as a system. The roller coaster system is made up of Earth, the track, and the roller coaster cars. The cars are pulled to the top of the first hill, usually with long chain that runs underneath the tracks. The chain provides the force that moves the roller coaster cars away from the ground. This force transfers energy to the roller coaster system. As the cars climb up the hill, the system gains gravitational potential energy. And that is the end of lesson 2. Make sure you've highlighted everything and move on to the next video.